All right, hello everyone. In today's video, I'm going to be going through the fundamental basics that you're going to need to know for the Chapter 7 test, including the slope-intercept form, the famous y equals mx plus b. Okay, we're going to be talking about how to graph. We're going to be talking about how to identify the m, how to identify the b, how to create an equation of a line, okay, given a point and a slope, table of values, all the things we've been practicing, okay? So let's first start with just the fundamental basics. So we've been practicing using the equation y equals mx plus b, where m is representing our slope, or our rise over our run, or the change in y over the change in x. Okay, and then our b is representing our y-intercept, and we've been using saying the word begin. B is for begin, m is for movement. So let's say I have a problem like this. Y equals negative 2x plus 4. Okay, so my m here is going to be the coefficient, or the number that's with the variable. So in this case, m is negative 2, and then my b value will be positive 4. The b value is the number that is not with the variable. So b is for begin, so I need to start on the y-intercept. Again, b is the y-intercept. It's on the y-axis. Okay, so as you can see, I put my first point, and then I'm actually going to write my m as negative 2 over 1. I'm just going to write it as a fraction. And when my numerator is negative, that means I go down, and when my denominator is positive, I go across. So as you can see, I drew those arrows in. So I go down 2 to the right 1, then down 2 to the right 1. And let me see if I can connect my dots. I know that's not a perfectly straight line, um, but close enough, okay? And you can notice that I put arrows on it. So again, I start with my beginning value, my beginning number, which in this case is 4, and then I talk about my movement, my m, my slope, okay? Now let's talk about something like this. If I gave you something like this, what if I gave you just 1/3 x? Well, common response I hear is, well, m equals 1/3, or the slope equals 1/3, and I agree. But then when we get to the b, we're kind of like, what's my b? There's no number there. What happened? What do I put? Do I say does not exist? Do I say nothing? There's that plus 0 that you can tack on to the end of that equation, okay? 0 is a number that doesn't materially change anything when you add it to something. So for example, if someone says, "Oh, here's $4," and then they say, "Oh, here's $4," and then here's $0 with that, well, you still have $4, right? Nothing's materially changed. So my b is just going to be 0, which again, I look at my y-axis, this up and down line, okay, that I'm kind of tracing with my cursor. So I start at 0, 0, which is the origin, right? And then my directions, numerator's positive, go up, and then denominator's positive, I go to the right. So up 1 over 3, up 1 over 3. I'm going to go ahead and connect those dots. Ooh, that was a really straight line. Good by me. Very nice. Okay. So again, that b value for begin, it's always going to be on the y-axis. It's the y-intercept value. It's going to be on the y-axis. All right, let's say I had something like this. Let's say I gave you something like this. Let's say I gave you x equals negative 2. X equals negative 2. Well, if I plot a point where x is negative 2, in this case it would be negative 2 comma 0. Could also plot this point, 2 comma 3. Could also plot this point, 2 comma negative 4. Notice how all of those points share an x coordinate of negative 2. Oh my gosh, I didn't label this. Whoops, sorry. There we go. Forgot my negative. So all of my x coordinates are negative 2. So when I connect those dots, decently straight line. Okay, it's a vertical line. I think the best way to think about these type of problems is just to, again, if it's saying x is negative 2 or x equals negative 2, just plot the points on the coordinate plane where x is equal to negative 2. It really doesn't even matter what points you pick. I just pick these 3 points and then connect the dots. Okay, now my question is, what's my m value and what's my b value? okay? So again, when you have a vertical line, that's one of those special cases. It's undefined. Okay, you could think about Skier Joe. If Skier Joe's going on the mountain, that's a straight down. That's a straight down drop. All right, can't find him anymore, so he's undefined. And then our B again, if our B is our y-intercept, well, there's no point on this red line that touches the y-axis. So I'm going to say DNE or does not exist. Okay, does not exist. So again, when you have these special cases, just take that extra second, think about it. It's telling me x is -2, x equals -2. Plot all of the points, okay, where x equals -2. All right. Let's talk about one where you have something of this. So I'm just erasing. Let's talk about something like this. What if you had like y equals 4? Again, same idea here. Let's just plot some points where my y coordinate is 4. So here, 1, 4, 4, 4, -3, 4, and so on. All right. Oops, that is definitely not a straight line. Okay. And then again, I just connect my points. When my line is horizontal or straight across, you could think about Skier Joe. Well, he's just, he's not going up, he's not going down, but he's staying, he's happy, he's at 0. So my M is 0. In my B, I do have a y-intercept here because notice there is a point where that line touches the y-axis, and that's at 4. Okay, specifically, this point is 0, 4, but you're picking the y coordinate, hence the name y-intercept. All right, y-intercept. All right, let's talk about if you had to write an equation from a graph. If you had to write an equation from a graph. So let's say you saw something like this. Okay, let's say they gave you this graph. Try and get it as neat as I can. All right, so the first thing I would do is I need to identify my M and my B values. So I always like to start with B for begin. All right, so on my y-axis, where am I beginning? What point? Well, the ordered pair, 0, -2. So my B value is -2. Now I have to think about how am I moving between the 2 points? How am I moving between the 2 points? All right. From this point here down to this point, I go down 1, 2, 3, just 3. Okay, so when I go down, that's a negative rate of change, so -3. Then to the right, 2. That's a +2. Okay. So then my slope would be -3 over +2. Okay. So now that I've got my M and my B, all I have to do is plug it into my equation. Y equals -3 over 2 times x minus 2. Some people may be asking, okay, does it matter where I put the negative? As we've talked about, it's always a good idea to put that negative, okay, with the numerator. When you're dealing with a fraction, put it with the numerator. All right. Let's talk about if I gave you a line like this, or I gave you the equation of a line like this. What if it looks something like this? Okay. What would the equation of this line be? Well, the first thing I notice is that my slope, my M, is undefined. Okay, it's that straight up and down line. Skier Joe fell off the cliff. And then my B, or my y-intercept, again, there's no point on this line that touches the y-axis, so does not exist. Now, looking at the M and the B, I've got an undefined and I've got a does not exist. This kind of, at a first glance, ooh, how am I going to write the equation? Again, just pick some points and label them. 2, 3. This is, what is this? 2, 0, 2, -3. Notice how they all have a 2 in the x coordinate. X is 2. Is another way of saying equals. X equals 2, right? I think that's the best way to think about it, is that when you have those special cases where it's a straight up and down line or straight across, plot the points, plot 2 points, plot 3 points, label them, and then look to see what they have in common. If they all have the same x value, then it's x equals whatever that number is. Okay, if it's the y value, then it's y equals whatever that number is, right? Let's talk about sorry, I gotta shift over here. Let's talk about something like this, where you have to create the equation of a line given a table. So you're going to see something similar to this, where you have your x and y table, all right? And let's say you see something like this, okay? All right. So my first step is I need to figure out what my slope is, all right? And another way of thinking about slope is the change in y over change in x. So if I look at how my y's are changing, well, they're going down by 3's, okay? So my y is -3. My change in x, okay, I'm going up by 2's. So I have -3 over +2. So that's my slope. Now, to figure out the y-intercept, the y-intercept is where the x value is equal to 0. So in this case, where the x is 0, my y is 10. So my b value is equal to 10. So then the equation for my line is equal to y equals -3 over 2 times x plus 10. Again, sort of two components to these type of problems. You look for the change in y, you look for the change in x. So you write it as change in y over change in x. Okay, and then you're looking for where the x value equals 0. Okay, where the x value equals 0. All right, we're going to try another one. This one I'm going to kind of step up the difficulty a little bit. Keep everything else the same. All right. So let's talk about if I gave you something along these lines. Let's do 1, 2, 3, 5, 10. Okay. And then let's say 3, let's do 3, 5, 7. Sorry, I'm trying to do this in my head. 11, then 20. Hold on. Sorry. Oops. Okay. Sorry about that. All right. Just wanted to double check something. Okay. So if I gave you something like this, all right, let's look at the change in y. So 3 to 5 is +2, 5 to 7 is +2, 7 to 11 is +4, and 11 to 21 is a change of +10. Now you may be noticing, uh-oh, my changes are different. Well, that doesn't mean that I still can't have a slope, okay? Because you have to check what my change in x's are. 1 to 2 is +1, 2 to 3 is +1, 3 to 5 that's a change of 2, and 5 to 10 is a change of 5. Okay, if I'm looking at all of these, well, that's going to give us a bit too many circles. Okay, 2 to 1, or a change of 2 over 1, that's equal to 2. Again, 2 over 1, I'm just looking at the matching pairs. 4 over 2, that simplifies down to 2, as well as 10 over 5, which also simplifies down to 2. Okay, also simplifies down to 2. So I know that my slope, my m, is equal to 2. Now the question is, well, where does my x value equal 0? And in this case, as you can see, there's nowhere where x is 0. So what I'm going to have to actually do is extend the pattern. So this is where 0 would go. So then I have to figure out, well, what number, okay, what number do I need to start at? When I add 2, I get to 3. And that would be 1. Do you see it follows the pattern? A slope of 2, a change of 2 over 1. Okay, so to go from 1 to 3, that's a change of 2. To go from 0 to 1, that's a change of 1. All right, so then my y-intercept would be +1. Again, that's where my x value equals 0. So then my equation will be y equals 2 times x plus 1. All right. So on a problem like that, it's the same principle, it's the same idea. You're sort of just extending the thought, so to say. All right. So that's slope and intercept, y-intercept from a table. All right. Let's talk about, excuse me, finding the slope from 2 points. Okay, that's where we use that formula, specific formula we've been working on, of y2 minus y1 over x2 minus x1. So let's say I pick the points 2 comma 4 and I don't know, -1 comma 3. First thing I do, label x1, y1, x2, y2, then I plug it into my formula. Okay, the most important part is right here, the labeling. So I do 3 minus 4, -1 minus 2. That gives me -1 over -3. This is not a simplified answer. You can't have a negative divided by a negative. You need to reduce it, properly reduce it down to 1/3. Okay, negative divided by a negative is a positive. Okay. So again, on these types of problems, all you need to do is label the x1, y1, x2, y2, plug it into your formula, evaluate, and then reduce. All right. This particular concept is fairly well understood. The component or the concept that I think maybe additional consideration or additional, need to think about is where I give you a slope and I give you a point. Actually, let's make it nice. There we go. I give you a slope and I give you a point, and I'm asking you to write the equation, okay, of the line that passes through that point and has that slope. Common error is to do this, right? -1/2 times x, and then just instinctively putting +4, since that's the y coordinate. But again, the b value is the y-interceptor when x equals 0. So in this case, I'm going to have to solve for b. So I'm going to label this x comma y. So I'm going to use the formula y equals m times x plus b. All right, y is equal to 4, m is equal to 1/2 times x, which is equal to 2 plus b. So -1/2 times 2 is -1 plus b is equal to 4. Now I add 1 to both sides, and I'm left with b equals 5. Again, I'm not done. Need to plug that back into my original equation. I'm left with y equals, in this case, 2 times x, because whoa. Nope, my slope is -1/2, -1/2 times x plus 5, all right? And that's the equation of my line, all right? These are sort of the fundamental basics, or sort of the fundamental concepts that are going to be helpful when working with these type of problems. Again, being able to recognize the y equals mx plus b formula, being able to determine slope, to being able to determine the y-intercept or your b value, all right? And then when we get to stuff like this, all right, again, thinking about the formula y2 minus y1 over x2 minus x1, labeling, plugging in points, okay? So again, these are sort of the fundamental skills that should be helpful for you as you go in and prep for the test. Anyway, thanks for watching the video. Hopefully, yeah, I didn't make it too long. That's good. Okay. And of course, as always, any questions, feel free to reach out. Thanks. Bye.